This video is on power models, and we are going to specifically look at patterns to recognize graphs. So in case you don't have a calculator or you just have to be able to pick out which graph goes with direct and inverse, if we have a positive or negative, we want to be able to find the three things that help us know what graph goes with what equation without the use of a calculator. So the first thing we're going to look at is direct versus inverse. If you have a direct variation, you'll know that it is a direct variation equation if you have a continuous graph. And it also needs to go through the point 0, 0. All direct variation graphs must go through 0, 0. So a continuous graph. Now an inverse variation won't be continuous. So inverse variation graph will be a discontinuous graph. And it does not cross the x or the y axis, or it doesn't have a meaningful one. And these are actually what we call asymptotes. Asymptotes. It's where it approaches a value but never actually touches it. So a lot of times you'll see as x approaches positive infinity, so as x approaches it to the right, as it goes to positive infinity, the y value will generally go towards 0, but it won't actually cross it. So if you remember back to direct and inverse variation, the end behavior, you have asymptotes, and the end behavior changes from as x goes to infinity, y goes to infinity. It goes from as x goes to infinity, y might go to 0 or a very specific value because that's where the asymptote is. The next thing we're going to look for is if we're going to have a positive versus a negative. And to determine that actually comes from our k value. So again, we're going to be looking, the positive versus negative is the k. So if you're looking at the equation or if you're looking at the graph, you'll be able to know which one goes to which. So if it is a positive, that means your k is greater than 0. Your graph has to go through quadrant 1. It has to go through quadrant 1. If your equation is negative, which means your k value is less than 0, your graph will actually go through quadrant 4. So just as a reminder, if you're dealing with your x and y coordinate plane, quadrant 1 is the top right. Quadrant 2 is the top left. 3, and then 4. So if your graph is positive, it has to go through this quadrant here. If it's negative, it has to go through quadrant 4 because it's reflected over the x-axis. The last thing we look for to help us is if we have an even exponent or an odd exponent. The reason we look for this is to tell us the other half of the graph. So we already know the first half is either going to be in quadrant 1 or quadrant 4. So then we need to know, will the rest of the graph be in quadrant 2 or quadrant 3? For it to be a function, it can't be in 1 and 4 because it wouldn't pass the vertical line test. So we do need to make sure that we have this half of the graph covered as well. So for an even exponent, you will actually have side-by-side quadrants. Which means, for example, you could if you have 1, you'd also have quadrant 2. But if it went through 4, it would also have to go through quadrant 3. So side-by-side quadrants are 1 and 2, or 4 and 3. So again, the 1 and 4 depends on if it was positive or negative, and then the other quadrant depends on if it was an even or an odd exponent. So then we also have if it is an odd exponent. So an odd exponent, it's not going to be side by side. They'll be opposite or diagonal quadrants. Opposite or diagonal quadrants. Opposite or diagonal quadrants. So that means that if it started in 1, the diagonal or opposite of that would be 3. So that's 1 and 3. Or if you started in quadrant 4, it would be 4 and 2. We're going to do some examples of how to of a basic sketch of the graph given the equation. These are the 3 things we look for to determine the basic sketch of the graph, or if we have a graph, to determine what kind of equation it would be. But then we also have one more thing about the k-value, because the k-value will change the shape of the graph slightly. If it is a direct variation, the absolute value of k, so that's just talking about the value of k, not necessarily the positive or negative, it's just the value of k. On a direct variation, if that value of k is greater than 1, the graph is actually more steep. So it actually goes up quicker. But on inverse variation, because it's the inverse of this, the absolute value of k, so again, that's just the value of k, the positive value of k, when that's greater than 1, the curve that we're going to have, because it will curve, because it will not cross through the axes, the curve is going to be further from the origin. Curve is further from the origin. So it will be further away from the origin. So we're going to use these to help us graph a basic sketch given the equations to know what it would look like.